Mr. Math AT guy. This is College Algebra, Section 1.1. We're looking at reviewing of fractions. Let's start out with a nice little joke here. What did the fish say when it swam into a wall? Damn! Now that we loosened up the air a little bit here, in this lesson, you will be able to understand what a fraction represents, which is objective 1. You'll be able to write fractions in lowest terms. You'll be able to multiply and divide fractions, and you'll be able to add and subtract fractions all together. Alright, so first off, we need to know what the definition of a fraction is. A fraction is a number in the form a over b, where a and b are both numbers, but b cannot equal 0. A is called the numerator, that's the top, and b, the bottom, is called the denominator. Pretty simple. B is not allowed to be 0, because if you have something 5 over 0, how can it exist? How can you have 5 of something if 0 of them exist? So that doesn't make any sense in our process here. So B is not allowed to be 0 at the bottom. Examples 1 through 3 here, we're going to identify the shaded portion in the figure. So we look at it. Green is the shaded part. It starts with 1, 2, 3, 4, 5, 6 pieces. It looks like 1, 2, 3 of them are shaded. So our answer is 3 out of 6. But is that in simplest form? No. So we're able to divide by 3, top and bottom, giving me 1 over 2 for our final answer. Number 2, we look at it, looks like there's 2 slices of pizza left out of 3. So we have 2 left out of 3. Can that be reduced? Nope. So we leave our answer as 2/3. And finally, the last one doesn't look like the picture is complete, so we probably should complete the picture. Looks like we could have one more line here, completing that off, giving us a total of 1, 2, 3, 4, 5, 6, 7, 8. But there, how many was to start with? 1, 2, 3, 4, 5, 6. So it looks like there was 6 out of 8. Looking at that both of these two numbers are even, we know it can be reduced. So we'll divide both top and bottom by 2, giving me 3 over 4 for my final answer. How are we feeling so far? Okay, moving on. A fraction is in lowest term when the numerator and denominator have no common term except 1. So in order to put a fraction in lowest terms, you need to know about factors. Okay, so this next section is we're going to be talking about factors. So 18. 18, we're going to figure out what are the factors for 18. What can go into 18? 18 is divisible by what numbers? So what are these factors? So, well, we know that 1 times 18 will give me 18. 18's even, so the 2's got to go in there. 2 times what gives me 18? 9. Let's try 3. Can 3 times anything give me 18? 6. Try 4. Does 4 go? No, 4 doesn't work. How about 5? 5, nope, doesn't end in a 5 or a 0, and 6 we already used. So the factors end up being 1, 2, 3, 6, 9, and 18. 15, right? 15, we look at it, we know 1 times 15 will give me 15. Is 15 an even number? Nope, so 2 won't work. Does 3 go in? 3 times what gives me 15? 5, good, because it ends with a 5 or a 0, so 5 is a multiple of it. Try 4, doesn't look like it works. And 5 we already used. So our numbers are 1, 3, 5, and 15. Take a second, pause this video, try number 6 on your own. See if you can do the factors for 24. So we have 24 times the 1, that's going to give me 24. 2 times what, because it's an even number? 12. 3 goes into 24 times 8. 4 goes into 24 times 6. 5 doesn't work, and 6 we already used. So it's a long list of 1, 2, 3, 4, 6, 8, 12, and 24. And number 7 is 11. We look at it, we got 1 times 11. I can't think of anything else. So 1 and 11 are only in the factors. Which brings us to the next part of the lesson. Prime numbers. Definition. A prime number is a natural number whose only factor is 1 and itself. So 11 would be a prime factor. What is the list? Let's list the first 6 prime numbers that we have. Well, the first number I can think of is 2, because it's only divisible by 2 and 1. 3, 5, 7, 11, 13, and so on. By the way, 2 is the special number. 2 is literally the only even prime number. Otherwise, if it's an even number, you know it's divisible by 2, which means that it's not. And if it's not a prime number, it is a composite number. A composite number, it's a natural number whose factors other than 1 and itself. So like up here, we're 18, 15, 24, those were all. But in our case, if the first 6, we got 4, 6, 8, 9, 10, 12, and many more. Knowing that, we're going to be able to reduce our fractions in lowest terms. That's questions 9, 8, 9, and 10. Looking at 8 over 14, what do you notice about these two? They're both even numbers, so they're at least divisible by 2. So let's try it out. If I do 8 divided by 2, 2 times what gives me 8? That's 4. And if I divide the bottom by 2, because what you do the top, you do the bottom, you get 7. So the answer is 4 over 7. Number 9, 48 and 42, they're both even numbers, so we can try 2. But we'll just spend time if we stay at 2. We'll have to do it again and again and again. So is there anything else you can think of that can go into both of these? If you said 6, you would be correct. Because 7 times what gives me 48? 6 times what gives me 48? Well, that's 8. And 6 times what gives me 42? That's 7. So 8 over 7, and we can leave it as that improper fraction. And lastly, once again, 24 over 36. Both are even numbers, but the largest number that could go into both of these would be 12. So top becomes 2, bottom becomes 3 for 2/3. So these are equal to each other, 2/3 and 24 over 36. Hopefully things are going well for you right now. We're going to take the next step into multiplying fractions. To multiply fractions, here are the directions. You multiply the numerators together, and you multiply the denominators together. So in this procedure here that you notice, a over b times c over d is going to equal a times c, because those are the numerators, and b times d, those are the denominators. And b nor d can equal 0, otherwise it's undefined. So in the example off on the side here, we'll do 2 times 3 on top, and on the bottom 7 times 4. Doing that math, we get 6 and 28. Can that be reduced? Yes, it can. They're both divisible by 2, giving you 3 over don't you take a second and try maybe 11, 12, and 13 on your own by pausing this and then seeing if your answers will match mine. And I'm going to continue, so pause it now. In 11, you could multiply across, but because this course is without a calculator, we're going to simplify our diagonals if we can. Well, 21 and 21 are multiples of it, so I can simplify these to be 1 and 1. Do 10 and 5 have 10 and 25 have anything in common? If you said 5, you'd be correct. Divide this by 5, which means this is a 2. Divide this by 5, and this would be 5. So we can look at the fraction of 2 over 1 times 1 over 5, which now is simpler to multiply. 2 times 1 is 2. 1 times 5 is 5. 12. Do the same thing. Look to see if the diagonals are multiples, have multiples of each other. Well, 15 and 25 looks like they're divisible by 5s. And 8 and 32 look like they're multiples of 8. So doing that, we get 1 over 5 times 3 over 4. Multiplying across, 1 times 3 is 3. 5 times 4 is 20. And 13, 21 and 7 are both multiples of 7, so we can divide those by 7. And 8 and 32, once again, are multiples of 8. So when I do that, I get 4 over 3 times 1 over 1. And 4 times 1 is 4. And 3 times 1 is 3, leaving me my answer of 4/3. Division, very similar, but in the division, you're not allowed to have you're going to let A, B, and C, and D represent numbers so that B, C, and D do not equal 0. So we're not allowed to have 0 in the denominators or in the top numerator of C. Okay? So the procedure is, what you do, you take the second term, you do the reciprocal, which means, in layman's terms, flip. So you can take it, and you're flipping the top to the bottom and bottom to the top, and you're changing the division to multiplication. So in this example here, you leave 15 over 12, and you flip it to 6 over 15. Before we multiply, because we don't like big numbers, let's simplify our diagonals. 15 and 15 could be reduced by 15 to go 1 and 1. 6 and 12, both divisible by 6's. So we get 1 over 2 times 1 over 1. Well, final answer, 1 over 2. Okay. I'd do the same thing again. I'd pause it now and try 14, 15, 16 on your own, and then come back and check your answers with mine. So in example 14, we got 3 over 8. The rule says to change it to multiplication and use the reciprocal of the second term, so it becomes 11 over 10. Can we simplify any of the diagonals? 8 and 11 don't work. 3 and 10 don't work. So multiply across, and you get 33 on top, and you get 80 on the bottom. So that's our final answer. 15 is a little tricky, because any whole number is over what denominator? If you said 1, put yourself a gold star. So we're looking at 3 over 2 divided by 9 over 1. So using our technique, 3 over 2, change to multiplication, you're going to flip it to 1 over 9. Is there anything in the diagonals that we can simplify? 3 and 9 are both divisible by 3, so this becomes a 1 and a 3. And multiply across. 1 times 1 is 1. 2 not least, flip this guy, second term, use the reciprocal, so we stay as 3 over 10 times 16 over 9, and we simplify. 3 and 9 are divisible by 3, giving me 1 and then 3 down here. 10 and 16 are both divisible by 2, giving me 5 and 8. Multiply across, 1 times 8 is 8, and 5 times 3 is 15. 8 times over 15 would be our answer. An improper fraction, which is the next key point here, is the numerator is greater than or equal to the denominator. So our goal is to leave things in improper fraction form. So in this case, we're going to take a mixed number and we're going to change it into an improper fraction. The process is simple. Take the whole number in front, multiply it by the denominator. So you're going to do 1 times 7, equaling 7. Then you add the numerator to that number. So 7 plus 1 is 8. That is your new numerator. Your denominator stays the same at 7. Try it on your own. 4 times 5, 20. Add the numerator. 20 plus 2, 22. So we have 22 over 5. And lastly, 9 times 4. Add the numerator. 36 plus 3, giving me my new numerator of 39 over 4. I'm hoping this is picking up. If you need to, go back, retry it again, slow it down, do whatever you need to do. But we are coming to the end here pretty quickly. To add and subtract fractions, the denominators must have the same common denominator. So you noticed in multiplication and division, you do not have to have the same common denominator. Multiplication, you went straight across. In division, you did the reciprocal and then multiplied straight across because you made it into a multiplication. So no common denominator there. But when adding and subtracting, the only way that you could add and subtract is that they have to have that same denominator. So basically what you need to do is the two fractions have to have an LCD. What is the least common denominator that they have? So for fractions, you're going to rewrite them each with a new denominator. So what happens is you look at the denominators. 6. 6 has multiples of what? It has 6, 12, 18, etc. 9 has 9. 9 times 2 is 18, 27, etc. What is the first thing that you see in common? 18. So my LCD ends up being 18. Try the next two on your own. Once again, pause this. 4, 8, 12, 16, dot, dot, dot. Next one, 6, 12, 18, dot, dot, dot. Because what do we notice? 12 are in common. So 12 is my LCD. And lastly, 5, 10, 15, 20, 25, 30, 35, 40, and so on. And 8 goes 8, 16, 24, 32, 40, dot, 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 dot. And the first number that is in common is 40. So in this case, 5 times 8 and 8 times 5 would have gave you 40. So to the last part of it, it's the objective of adding and subtracting fractions. Write your answers in lowest terms. So do they need a common denominator? Hopefully you said yes, because that would be the correct answer. times what's going to give me 12? That would be 3. So you multiply top and bottom. So we leave 7 over 12, and we're going to subtract 3 over 12. Common denominator, so the 12 stays in the denominator. Top, we do the math. 7 minus 3, which is 4. Can we leave 4 over 12? Nope, because it's not in lowest terms. So we divide top and bottom by 4, and we get 1 over 3 for my final answer. Lock it in. Lock it in. In number 24, we need an LCD. LCD looks like it's going to be 16. So we multiply this over here by 4, top and bottom. So we have 3 over 16, and we're going to add 20 over 16, which we do the math and get 23 on top over the denominator of 16. And we can't do anything because 23 is a prime number. We need an LCD between 6 and 8. Our LCD ends up equaling 24. So 6 times what gives me 24? 4. And 8 times what gives me 24? 3. Simplifying it, 8 over 24 minus 3 over 24. 8 minus 3 is 5 over 24. Last three, we look at it, we need an LCD. LCD between 5 and 3 is 15. So we'll multiply this side by 3, these by 5s. End up with 6 over 15 plus 50 over 15, giving me a final answer of 56 over 15. Before you can subtract a mixed number with a fraction, you need to change this to an improper fraction. So do what we do. 3 times 2 is 6. Add the 1. So we get 7 over 2 minus 3 over 2. And so nicely that they already have the common denominator. So we can do the math. 7 minus 3 is 4 over 2. We're not allowed to leave that. 4 over 2, it is 2. Don't give me 1/2 because the bigger number is on top. So it's 2 over 1 if you're going to do anything. And lastly, 4 over 11 is okay. And we're going to add whatever this mixed number turns into an improper fraction. So 2 times 3 is 6 plus 1, 7. So we get 7 over 3. The LCD is 33. So we do times by 3 times by 11. So we get 12 over 33 plus 77 over 33. And we're going to add it and get 89 over 33. Hopefully this lesson made sense to you and it was very useful. If you were absent, I hope you felt a little better now. So this is Mr. AT Math Guy